In this video, we're going to begin our discussion with hypothesis tests for a population proportion. Recall, the best point estimate of P, the proportion of the population with a certain characteristic, is given by P hat is equal to X divided by N, where X is the number of individuals in the sample with the specified characteristic, and N is the sample size. So we've learned earlier that the sampling distribution of P hat is approximately normal with the mean equaling P, and the standard deviation is equal to the square root of P times 1 minus P divided by N, provided that the following requirements are satisfied. Number 1, simple random sample, or the data results from a designed experiment. We also need to check that N times P times 1 minus P is greater than or equal to 10. And 3, the sampled values are independent of each other, meaning N is less than or equal to 0.05 N, or the sample size is less than or equal to 5% of the population. Okay. All right, so let's consider the following. A researcher obtains a random sample of 1,000 people and finds that 534 are in favor of banning cell phone use while driving. So P hat is equal to 534 over 1,000, and I can rewrite it as 0.534. Does this suggest that more than 50% of people favor the policy? Or is it possible that the true proportion of registered voters who favor the policy is some proportion less than 5/10? And we just happen to survey a majority in favor of the policy. In other words, would it be unusual to obtain a sample proportion of 0.534 or higher from a population whose proportion is 5/10? What is convincing or statistically significant evidence? Statistically significant when observed results are unlikely under the assumption that the null hypothesis is true, we reject the null hypothesis. Okay, hypothesis testing using the p-value approach. The p-value, the probability of observing a sample statistic as extreme or more extreme than one observed under the assumption that the statement in the null hypothesis is true. In other words, the p-value is the probability that a sample will result in a statistic such as the one obtained if the null hypothesis is true. So, hypothesis testing regarding a population proportion using the p-value approach. If the probability of getting a sample proportion is extreme or more extreme than the one obtained is small under the assumption that the statement of the null hypothesis is true, we're going to reject the null hypothesis. So in other words, the lower the p-value, the stronger the evidence is against the statement in the null hypothesis. Well, more precisely, if the p-value is less than the type 1 error, which is alpha, we reject the null hypothesis. So to test hypotheses regarding the population proportion, we use a z distribution, and I've given you the particular formula. Now, in another video, I'll show you how to use the z table in order to use this particular formula to determine what to do. But on the side, I've come up with the 3 different types of tests that you can have: the two-tailed, the left-tailed, the right-tailed, what it would look like with a picture using the z value, and how you'd write out the null and the alternative hypotheses. Okay, let's take a look at an example. An educator estimates the dropout rate for seniors in high school in PA is 14%. Last year, 40 seniors from a random sample of 200 Pennsylvania seniors dropped out. At alpha equal to 0.05, does the sample suggest that the dropout rate in PA has stayed the same? Justified your position. Okay, so what do we have? We have one population. We have a proportion. And it's a hypothesis test. And we have a feeling it's a hypothesis test because the alpha is equal to 0.05. Okay, so we need to make sure the conditions are met first. So let's write those out now. Okay, so it's a simple random sample. We need to check the n times p times 1 minus p is greater than or equal to 10. Well, n is 200 in this case. P is 14 hundredths because we have the percentage being 14%. And then 1 minus p is 0.86. That gets me to 24 and 8/100 greater than or equal to 10. And 200 is less than or equal to 5% of the total number of high school seniors in PA, which means I can use the hypothesis test. Now, we need to be able to write out the null and the alternative hypotheses. So, the null for us would be P is equal to 0.14. The alternative hypotheses. Well, let's take a look for key wording. Okay. Well, stayed the same. That seems to be the key. So it looks like in this particular case, the alternative hypotheses would be P does not equal to 0.14. Okay, now that we've written out the null and the alternative hypotheses, it's time to show how to put this in the calculator. So let's do that now. Okay, now that you have the calculator, how do we do this? Hit Stat, highlight Tests, and then we're going to look for 1prop Z test, which in our case is number 5. Hit Enter. The P is 0.14. The X is 40. The N is 200. It's not equal to P sub 0. Highlight Calculate and hit Enter. So, the P that we want at this particular case, the P value, is the decimal in the third row. So again, I will round this to 4 decimal places, which would be 0.0145. Okay, so let's put this on the paper then. So on the paper, I'd want you to write 1prop Z test, parenthesis, the P, 0.14, the X, which is 40, the N, which is 200, and here it's P does not equal P's of 0. And underneath, I rounded the P value to 4 decimal places. So now what are we doing? We're checking to see if the P value is less than the error. Well, the P value is this. The error is 0.05. Is that P value less than the alpha value? And the answer in this case is a yes. So what do? We're going to reject the null hypothesis. So now I'm going to write out the conclusion for this with respect to this problem. There seems to be sufficient evidence at the alpha equal to 0.05 level of significance to conclude the dropout rate of high school seniors in PA has changed. Okay, let's take a look at the next example. A statistician read that more than 75% of the population opposes replacing $1 bills with $1 coins. In a recent poll, the statistician selected from a random sample of 80 people found out that 55 were opposed to replacing the $1 bill. At alpha equal to 0.01, does the poll support the claim? Justify your position. So again, what do we have here? We have one population, certainly have a proportion, and we know this is going to be hypothesis testing. Okay, now let's make sure the requirements are met here, so I will write those out now. Okay, so this is a simple random sample. Again, we need to check n times p times 1 minus p is greater than or equal to 10. N is 80, the p is 75%, so that I can rewrite that as 75 hundredths. And then 1 minus p is 25 hundredths. Multiply, that's 15. 15 is greater than or equal to 10. And then 80 is less than or equal to 5% of the population of people. Okay, so now we need to write out the null and the alternative hypotheses. So the null would be what? P is equal to 0.75. Alternative. Now we got to look for key wording here. So in this case, more than. So the alternative hypotheses would be P is greater than 0.75. Okay, well, what exactly would I put into the calculator at this stage? It would be what? 1 prop Z test, and it would be 0.75. That's the P, comma, the X, 55, comma, 80, comma, p would be greater than p sub 0. Okay, so let's put this into the calculator now. Okay, so how do we do this? Stats, highlight tests, and again, we're going to scroll down to number 5, one prop z test, hit enter. Okay, the p is 0.75, hit enter. X is 55, hit enter. 80 is n. And then again, highlight greater than, hit enter. Scroll down, highlight calculate, hit enter. Third row down is the p. So again, I'll write it out as 4 decimal places, rounded correctly. That's 0.9016. So let's put that on the paper now. Okay, so the p-value. Right. So now, what are we doing? P-value, we want to check to see if that's less than alpha. P-value. Alpha, in this particular case, is 0.01. Is that decimal less than 1/100th? That is no. So what do we do at this stage? Do not reject the null hypothesis. So now I'll write out the conclusion below in the context of this problem. There is not enough evidence at the alpha equal to 0.01 level of significance to support the statistician's claim that more than 75% of the population opposes replacing $1 bills with $1 coins.